Equals what? What can we do now? What could we do to
You can
this?
solve for one of tan alpha or tan beta.
Solve for which one do you want to solve for?
Alpha's probably going to be easier.
Solve for alpha. Okay, solve for alpha. So what do we want to do here?
Well, you multiply both sides by tan alpha.
Sure. So 5 equals 3 tan alpha minus 2.
Factored out.
Okay.
Unfactored or
Okay, so
undistributed.
undistributed. I like that. 3 minus 2 tan beta. Like
And
that.
now divide both sides by 3 minus 2 over tan beta.
So tan alpha is going to be 5 over 3 minus 2 tan beta. So we have tangent alpha in terms of
Tan beta.
tan beta. Okay, that's something. Let's keep meandering here. We need theta in terms of x, right? That's what we were trying to figure out. What next? What should we do now?
Write the equation in terms of theta.
Write the equation in terms
From up
of
top.
theta. The equation in terms of theta. That's what we're trying to do. That's correct.
So now that you have
Yep. Beta is equal to tan inverse of what? What can we do with both of these things now? Add them together, right? So we know that. So therefore, we know that tan inverse of 2 over 3 minus x plus tan inverse of what? 5 over x plus theta is equal to what?
180.
180. That is correct. So we have something in term. We have theta, just in terms of what?
X.
What can we solve for at this point?
Theta.
Theta, thank you. So theta is equal to 180 minus this thing. There it is. Now what do we do?
Now you
Take the derivative.
wait. Don't you have to write the whole equation in terms of inverse tan?
Well, hold on, one sec. What was our, hold on. I understand what you're asking. Let's just pause for 1 second here. What was our goal? Writing theta in terms of x. Have we done that?
Yes.
Yes. Yes, we could change 180 into pi. Is that really going to matter at this point? What's the derivative of a constant?
0.
0, right? So what we're doing is finding d theta over dx. And why? Sorry, I got to be really careful with my notation here. That's a different. I need d theta over dx. This little thing later, you will use this in multivariable calculus. I should not write that. Is going to be equal to what? Well, you need to actually do. It's going to be the opposite of d theta dx of that thing right there. So what do you need to remember the derivative of?
Negative inverse trig function.
Yeah, you need the derivative of inverse tangent.
Yeah.
What is the derivative of inverse tangent?
1 over x squared plus 1.
Okay, so it's going to be negative, what is it? 1 over what?
X squared plus 1.
2 minus 3x, what?
Squared plus 1.
Plus 1 times what? D theta dx of what? 2 over 3 minus x, right? You need to kick that out? Do you agree?
Wait, it's 2, isn't it?
Chain rule. What's 2?
Okay. But are you taking the derivative in terms of x?
We're taking the derivative in terms of x, correct?
So isn't that just going to be 2 over 3 minus
Okay, I'll
x?
pause for a second. So they're both positive, so
they go
one.
because it's smaller than 3. Yeah, the total is
Oh, it has to be between x must be your, that's a very good point, thank you. So you know that x has to be like this, right? So therefore x equals 5 minus 2 root 5. You're absolutely right. That is a much better add. Okay, so that's what x equals. Great.
Also, you can also get 2 times root 5 minus 1 because that's the other.
Oh, you could get the other one depending on what you labeled. Absolutely, yes. 2 minus it, yeah, because that's the other one. I totally agree. So we're not done yet, though. What's this question asking for?
Max value of theta.
Max value of theta. So at this point, what would you need to do in order to get theta?
Plug in that value.
Plug in that value into
the
this right here. So we know that x is going to be 5 minus.
Well, actually, the question doesn't ask for theta though.
It doesn't?
Yeah,
It just asks for.
Yeah, it does. I thought it did. It
asks
says.
for
Well, it
max
says-
value of
Oh, it
theta.
says
What would
where should point B
would
be? Oh yeah, yeah. So yeah, that's where should point B. But we're actually really not done quite yet. What would you need to do? We're not done yet. This is the last thing we've hammered on. I've hammered on. You're not done yet.
Check that it's a maximum.
Is this a max or min or neither, right? In this case, what two tests do you have?
First derivative and second derivative.
First derivative test and the second derivative test. So do we have a first derivative test? We have a first derivative, right?
Yeah.
The first derivative turned out to be this thing right here, correct? Turned out to be that thing. Now you could, the advantage, what's the advantage to the second derivative test?
You only have
You only
to
have to check one number, one value. First derivative, you have to check two, but the disadvantage for the second derivative, you have to do the derivative again.
And
So if you do this out, let's see, they tended to like the first derivative test. And if you do the first derivative test, if x is less than, and it's actually pretty, you can estimate the value. If x is less than 5 minus 2 root 5, d theta dx turns out to be, if this is truly going to be a maximum, it turns out to be positive. And if x is greater than 5 minus 2 root 5, d theta dx turns out to be, it does turn out to be negative. So this is therefore where the max theta occurs. This is not where the max x occurs. This is where the max theta occurs. Now, could you figure out theta from here? Yeah, it doesn't ask that, but you need to prove it.
I'm curious as to how
Yep.
you simplified it.
Yeah.
Optimization problem.
Yeah.
If 12, oh, come on. There was nothing hard about this except the algebra. The only thing that made this hard right here was the algebra and knowing that what the tan inverse was, the derivative of tan inverse. You should know that. You have to know that. You have to memorize the derivatives of inverse trig functions. You have to. It'll be very difficult for you to score well on the AP exam if you don't memorize them. If 1,200 centimeter square material is available to make an open box with a square base, find the largest possible volume of that box. So you draw the box first, right? You draw this box. So if that's the box right there, we'll call that x, and what's the height? H. Let's use h for height. What's the volume of that box, therefore? H, correct? And this is an open top box, so this is open, right? What's the one number from the problem we haven't used yet?
1200.
We know that 1,200 is going to be equal to the surface area. How many bases are there?
1.
What's the area of the base?
X?
How many sides are there? 4 of them. And what's xh? What can you solve for? Which one do you want to solve for? Let's solve for h. You know that h is going to be equal to 1,200 minus over what? Over 4x. What do you do with this now? Plug it in here, and now you have, now that you've done that, you now have the volume, stop eating plastic, the volume in terms of just what? X is going to be x squared times 1,200 minus x squared all over 4x. Before we take a derivative, what should we do? Yeah, v of x is going to be equal to, so it's going to be 1,200 x minus x cubed all over what? All over 4, which is going to be equal to 300x minus 1/4 x cubed. We're looking for to maximize that, so we're going to take the derivative. That's correct. So we end up with v prime of x 300 minus 3/4 x squared. Correct. So you want to look for what 3/4 x squared is equal to what? 300. That's what you're looking for. So x squared is equal to what? 400. So x is equal to plus or minus 20, but we're looking for a real box that isn't extending into negative space. So x should be what? 20. How do we go about proving that that's the minimum really easily? Well, when the derivative is that nice, which test should you use?
First.
No, no, no. Use the second, because you can easily find v double prime of x is going to be negative 6 over 4x, right? And what is v double prime of 20? Negative 6 over 4 times 20, which is less than 0, right? So x equals 20 is at a max. Correct. And what's this ask for? It asks for find the largest possible volume. So how do you find, what do you need to find that volume? You need to find h, right? And what did h equal? H is equal to this. So now it's just a matter of algebra again. Just a matter of algebra. So h when x is 20 is going to be 1200 minus 400 over 80. So that's going to be 800 over 80, which is what? 10. So you know the box is going to be 20 by 20 by 10.
Way too simple.
Okay, put everything away because it's a pencil. What does this represent right here? Can someone tell me what this represents? What is that? Of a what?
Function.
Of a what type of function?
Linear.
So what is that? One word. One word.
Line.
That is a line. That is a line. Through what? Which one? X1, comma, Y1, right? Yep, that's correct. Y1, or in this case, f of x1, which is the same thing, right? Yep. Through that point with what slope? F prime of x1. So that right there is the line through that point with that slope. So what's another way to say that? What is that? That is a tangent line, exactly. You've done this many times already. That is a tangent line.
To that point.
It is tangent to f of x. It's tangent to f of x at x equals x1, yes. Tangent to f of x at x equals x1. So what have we done there? You have some function, it's traveling through space, right? And you picked some x value and you found the equation of the tangent line. This line, let's call x2 its x-intercept. How many times can a line cross the x-axis?
Once.
Once. The x-intercept is when what is 0? When y is 0. So we set y to 0. So we set y to 0 here. And we solve for, and we set when x is 0, we're saying x is going to be x2. What we solve for there is x2. So x2, just in terms of everything we know, is right there. So we did some algebra here. Great, it's 0, nice. We put an x2 right there, and then we solved for x2. So we just found the x-intercept of a line just in terms of its slope and the point that it goes through, starting with this point slope form. Are we okay with this so far? All we've done is we've isolated the what?
The x-intercept.
The x-intercept. Does it matter that we called it x2? No, we could have called it pony, right? But the point is we're calling it x2 because what are we going to find next? We're going to probably find another intercept, but I have to tell you what that is. So what's next, we're going to keep on doing this. What does that mean? It means we had some function. Here it is. Here is the x-axis. What did we just do? We picked an x value, right? We picked some x value. Let's say we picked, I don't know, this x value. We'll call that one x1. What did we do at x1? We went up to the point, right? And we found the tangent line. And then we took that tangent line and what did we do with it? We found the x-intercept. What are we going to do again? The same thing. We're going to start at x2 and what are we going to do? Find the, not point of tangency, we're going to find the
Tangent line of that.
Tangent line of at that x value, right? That's what we're going to find. We're going to find this point right there. What is that point right there? That is x2 comma f of x2, right? And what are we going to do? We're going to bring this back all the way to the x-intercept. And what is that x-intercept going to be? We're calling that x3. Once we get to x3, what are we going to do?
We're gonna take the.
What are we going to do? Summarize for one sentence. We're going to do
Exactly what you just did.
the exact same thing. We're going to, it might go down, right? We go down to the function value. We go to that point. And what do we do at that point?
Take the tangent line.
We find the tangent line, right? Or take it, I guess that's okay. And then we go up to here, right? And what is that value going to be right there?
X4.
x4. And what are we going to do at x4?
Do the same thing.
The same thing.
So it's
What's going on?
You're
Cons-
getting closer and closer to the x-intercept.
Getting closer
Oh, yeah,
and closer, I've mentioned this before,
yeah.
to the x-intercept of the function, right? Do you see it happening on that picture right there?
Yeah.
Yeah.
It's getting closer and closer, and actually gets close pretty quickly.
Yeah.
It gets close pretty quickly. So let's just do one more iteration. I'm not going to do the nth iteration here, but if I take this right here, let's just take this equation right here, and instead of x1, I'm going to put in, so we have this. We have this right here. So let's go to the second iteration, meaning we're at an x value of x2. So it's going to be y minus f of x2, right, equals f prime at x2 times x minus what? Agreed? Right? But what do we know x2 equals? Nope. Y is
It
0.
equals
x2 is
x1.
this thing. Right? No, x2 is this thing. We solved this, remember,
It
right?
equals the x-intercept at x.
Yes.
of
So
the tangent
look,
line
we
for x.
exactly. So we just isolated. What does x2 equal? x1 minus f of x1 over f prime of x1. We just figured that out above. So where are we going to plug that in? We're going to plug that in for x2. So what do we end up with? Y minus f of x1 minus f of x1 all over f prime of x1 equals f prime of this thing. What is it? x1 minus f of x1 all over f prime of x1. The bell rings, do not move. Times what? x2, right? Correct?
Yes.
Well, x2.
Oh, did I plug in the wrong thing right there? Sorry. So what is x2? Sorry, I gotta write that down again. Minus what?
X1 minus f of x1.
x1 minus f of x1 all over what?
F prime of x1.
f prime of x1. So this right here represents the tangent line, right? This represents the tangent line at that point. Agreed?
At
Yeah.
point 2.
At point x2.
In terms
of
F1.
f of x1,
yeah.
right? Correct? So if we wanted to find the x-intercept, we would set y equal to 0 and x equal to, what are we calling that? X would be equal to, we're calling it x3. And what would we solve for? Solve for x3. Does it get a little nastier?
Yeah,
It does.
Those two terms cancel out right there.
In the middle, what two terms cancel out? It's f of.
Oh, no, it's
They're very
multiplied,
different.
okay.
They're it's multiplication. Yeah, they
Yes,
wouldn't
I
cancel.
didn't see
So here's the thing. It looks pretty nasty, right? It looks pretty nasty. It's actually not bad because if you do this